So I started recording.
Yes. At least it says that that's something. Okay. I figured I would just start to talk about curl for a while. A little bit about last year, right now, and next year. And now you can certainly see that the brightness is away from this. But it doesn't really matter. I think we can read it. And as I said, I actually sort of struggled back and forth for a while how to count when we actually started curl. Did we start in 96 or did we start in 98? In 98, I renamed it to curl, but I mean the project started before, so it was actually mostly maybe 96. So that's why I'm struggling to put a specific birth date. But I've turned around more and more, so now this year we'll turn 30 in November. Okay, so I just wanted to, it's fun to do roughly the same talk at Curl. We've been doing Curl Up since 2017, and I've tried to do roughly the same comparisons how we have done over the years every time, and I think it's fun. It is fun for me, so you get to endure that. Now we're at 176,000 lines of code. We're actually 3,000 lines shorter than last time at Curl Up when I said this. So that's kind of I don't think I've ever had a negative like this in Curl Up. And I guess it's a rare occasion, but I mean, less good code is good, right? I'll get back a little bit to that. So if we look at the graph, we can also see that yes, we dropped, but we're certainly going up again. So it's, who knows, we're going to surpass the previous amount soon. Right, the curl tool is the red one over here. So the curl tool is kind of small in comparison, just 25,000 or something. Yeah, and as always, a fascinatingly linear growth over time. So it seems like that's the speed we can do, that's the growth we have, so we can just extrapolate where we're going to be in a few years, maybe. Other things that we just keep on growing is, of course, the number of man pages in the project. Yes, in 2014 we switched around, so we added one single man page for every option and every thing in basically every symbol in the cursor. And then we've been gradually increasing number of man pages, lines of documentation in the docs directory in the repository, also growing, of course, because we're adding stuff. But we're also adding more documentation per line of code over time, which I think is good, right? We're documenting a little bit more than we're writing new code, at least until the last few months. So I think this is a pretty good. We're keeping up at least. And one of my favorite graphs, of course, you know, I have a lot of graphs in Flashboard. One of my favorites is age of source code in the repository. Basically, all the different sediment series, like archaeology here. So all 2-year periods get a different color, and at the end we can see how much code from all the different eras remain in the repository today. This is just the production code, so this is tool code and library code. And apart from the projector being a bit dark now, so we can basically see that everything that we ever write, it enters and then squeezes down, and we have a little bit of code left from every 2-year section ever. My favorite is the one pre-2000, because there's still a little piece here. It's like, I think it's 900 lines of code from before 2000 that is still left in code.
May I ask how this is gauged? Because in our project we have a lot of lines touched recently because of different styling tools, and the actual code is decades older, but it's not very easy to see from the gateway.
Well, there are two explanations. First, don't touch code, and it remains the same, but then also use git blame CCC, 3 capital C's, because it makes a really good job of trying to find the non-copied code so that it actually works decently. But in our case, I think those 900 lines, they are genuinely not touched since late '99. And the thing is that we imported the code into SourceForge in December 1999. So, and then I didn't keep the history. So that is basically the first code according to Git history. Yeah, those are, I think, comments in a few source code headers or something, and a few source codes that have remain systems. So it's, I don't think it's actually source code, not some comments, maybe an if somewhere. And the interesting part is possibly that we keep changing a lot of code. So even though we added code, there's not a lot of old code left. And I have another graph that I sort of like, because this is hard to read, but it shows what we're doing. It basically counts how many number of lines of code have we added in Git and how many codes of line are still there, right? We have added more than 4 times the number of codes that are still there, meaning that we have, on average, rewritten every line of code in curl 4.14 times, which, it just shows that we're refactoring and polishing a lot. And what 2025 just took off. We're basically rewriting everything again. For some reason, I blame Victor. Yeah, just fun to see. And we actually removed one protocol in the Delta. We actually added one and we removed 2 over the last year. So that's we're down to just 27 transfer protocols or URL schemes that Perl supports. So we added MQTTS, we removed RTMP and RTMPS. No one ever uses RTMP anyway, we reduce. So the number of protocols we support, a lot. A couple of protocols less now. We've dropped support for 4 different third-party libraries, so now we only support 31 of them, like this. It's really hard to make the labels good on a graph like this, because how do you do? My GNU plot foo is not good enough to make it. Anyway, good. But yeah, I think we're going to try to keep on also getting rid of stuff that we don't use that's not good enough. So maybe we could trim this down even more in the next year. I'll get back to that later. How many operating systems code has it run on? It's really hard to say. I repeatedly show this one to people, and repeatedly people mention a new one that isn't already on this. And that's why I say 5 more this year, because 5 more people say, hey, we run curl on something that I added to this, because I think it's fun. It's a crazy amount of operating systems. However you want to define an operating system, because every time I show this, that also leads to discussion. What do you mean with an operating system? Is Mimo really a separate one? Yes. Anyway, it's a fun slide, I think. But and the number of CPU architectures is pretty stable, because they don't introduce CPU architectures that often. This is basically anything that is 32-bit that's being used, has been used. I don't know of any other 32-bit in existence, really. I basically don't know a lot about them either, but a lot of them. And we're still only on 2 planets. Presumably curl might be on the moon as well, but that's not a planet, right? Okay, yeah. So to just other things we've done, I think this summary of backend changes, the numbers within the parentheses show a little bit of what we've been doing. We're reducing things, right? We're down 1 TLS backend, down to just 11. It sounds a lot, but it's actually, a lot of them are OpenSSL forks, and they share the same source code, mostly. We're down 2 quick backends. We're down 1 resolve backend and 1 SSH backend. So we're trimming off a lot of things that aren't really used, and we don't want to keep maintaining, basically. Of course, nothing is forever. We're going to add new ones over time as well. So I'm thinking it's good to get rid of the bad stuff so that we make room to get new ones added and focused on. But yeah, really complicated graph, just showing that we're adding a lot of stuff over time, we're removing stuff, it keeps on changing. The good part about this is that we can still keep the API and the outside stable while we're reorganizing the engine like this. It's kind of crazy. And we added 6 new command line options this year, 273, and we have a whole bunch of new ones coming up. So it's not going to be the last ones. That also has this lovely linear graph, basically the same as the Limesol code. So this seems like natural in our project that we're adding about around 10 options a year, maybe a little bit less every year since a long time ago. The primary lib curl options is setting transfer things. That's the curl is set up, set options for how to do transfers. It now has 308 options, one more since last year. So at least that has grown a little bit slower, but still it keeps on growing, and that's going to grow more as well as we're adding more weird protocol and more combinations of things. We're going to continue to do that. And since we never remove anything, it's not going to go down. We sometimes remove functionality, right, but the options remain there. Because we can't break old applications, so the names are going to remain anyway, even if we sometimes remove functionality. And we're at exactly 100 API calls. Still decent, quite a lot, but we're holding down at least the growth. It has certainly not been exploding in the same way. We started with 20, 30 something when the first version of curl, and now okay, so it's 3 times the number of API calls since we started, but still, that's 26 years ago. One thing I actually did this year is that many things regarding to what memory consumption and what curl does in terms of allocating memory. So not only nowadays when we run test cases, a lot of test cases, a number of test cases actually have these limits. They're only allowed to use this much memory and this number of allocations. So just to make sure that we don't accidentally do something stupid and just would suddenly allocate a lot of memory or do many individual allocations, because that would be just stupid. We want to have those in check and control. So I went back and checked how much memory do we actually use for different kinds of things in curl and how much have we used over time. For example, the connect data struct in curl is the single struct we allocate per connection in curl. And when you're using curl, you could potentially use quite a lot of connections. So this is one of these per connection in curl. So it was just interesting to see how has that sort of transitioned over time. We've kept it in check. Now it's sort of below 1K for each connection. I think it's super okay. But that's not the only struct, right? So we have this easy handle, which is the handle we have per transfer. Transfers being sort of disconnected from connections. So you always have one per transfer, and you have possibly one connection as well. And we started out that really big back in the day, and we have shrunk that, so now it's about 5K per transfer. It's hard to shrink that further, but we want to mostly just keep it in check. And the multi-handle being the handle that keeps a number of concurrent transfers. So if you want to do a number of concurrent transfers, you need one multi-handle that holds a lot of easy handles that hold connections. So we just keep that, keep check of that, and that has grown up to 800 bytes, but still tiny overall. And then I have this total thing then. So how much memory does curl need? Curl in itself to transfer 512 megabytes. And 512 megabytes is just a randomly picked thing because I had that file lying on my disk. So I just compare then how much memory at the maximum peak and how many allocations does curl need to transfer 512 megabytes. And actually it doesn't matter how much data because 10 gigabytes is going to yes. going to be as many because we don't allocate them free on hot path. So yeah, nowadays we're then at a peak at a little bit of 130K and at 110 allocations. And I want to again then just preface, this is what curl does it in itself. And this is doing a clear text HTTP transfer. Because if we're using, for example, TLS, the TLS libraries are going to allocate things like crazy. But they are on their own, so we can't really change that, right? So we could keep track of our allocations and what we do, and the others keep track of their allocations. So I've not tried to include those. So I think we're keeping track, and I think the oldest one I've tried was 2018, but it still shows that since 2018, that's 8 years ago, it's roughly the same. The number of allocations have gone up a little bit because of internal refactors and how we model things, but still, the peak amount of memory is actually shrunk a little bit over time. So I think we're keeping things in check. And with these new CI checks and checks in testing, it's going to be difficult for us to just accidentally break this too. Of course, over time it might gradually grow. We're keeping things in, and back to Max's thing about doing fuzzing. So we're part of the OSS fuzz on Google, but it basically doesn't show anything new these days. It's very rarely actually triggering anything. It actually triggered something like a month ago, and that was basically just an assert in the build that happened. So it doesn't happen much. It's one of those things, we keep them there. It makes sure that every once in a while, a few times a year, it finds something, otherwise it just keep on trying things. Lines of documentation, that already showed it, yeah. Number of lines in the curl tool man page, 7,100 lines or something, huge. And that also means that the number of lines in the man page per option in 273 options, right? And it's on average like 27 lines of documentation per option. I don't know what it says. It says that it's a huge man page, impossible to find stuff in, but it documents a lot. One of the key things, of course, to do for us is to keep adding test cases for everything, every bug and every new feature, or at least we want to and we try to. So we added 255 test cases the last year. With 12% increase over the year, and year 30, I think that's pretty nice. Of course, what is a test case? A test case is actually a really bad metric, right? Because it could be a really simple single thing, or it could be a really huge, complicated test case, and we have all sorts of those, from the simple one to the really complicated one. So it doesn't really, it's just a weird metric, but it's one way to measure that we're actually trying to keep on adding test cases. And we're adding test cases at a higher pace than we're adding code, at least. So number of lines of code, number of lines of test cases, and actually the number of test cases per 1,000 lines of code is gradually increasing too. So I actually checked the other day when I did this screenshot, so I actually checked. So we're so close to 13 now. It's like 12.995 test cases per 1,000 lines of code. Anyway, I think this is just a fine development because it shows that we're keeping an eye on adding test cases, and test cases are always good, right? Of course, we still miss out on a lot of things, so whenever someone reports a bug, it shows that we didn't have a test case for that, and we try to fix that. So yeah, we have a lot of lines of test infrastructure code. We actually have more test infrastructure lines of code than we have production lines of code. But that's not surprising. This, over the last few years, I've struggled, or maybe you know this, but I've worked really hard on reducing complexity of curl functions. Basically, I have this script that shows here's the top list of the most complex functions in curl, according to the McCabe tool in Debian. And it basically just counts cyclomatic complexity of a C function. Whatever that is, it's basically indentation level, size, and number of loops and stuff, number of expressions and comparisons in the function. I mean, it's not an objective truth, but it's one way to calculate complexity, and I think it's decent. And my effort has been over the last few years to make sure that our worst functions should be better. And this shows, this is the average and the median complexity of all functions in curl. Basically just showing that the average complexity of functions in curl have dropped significantly, because I've been picking the most complex one, refactored that, and when I've done that, I pick the next one that is worst and worst, and then I've done that for the last, I don't know, 2-3 years, and over time it will show. I have this other fine graph, but maybe not that visible on the screen here, but this shows how big chunks of the curl code that has what complexity level. And if we look at the legend here, we can see that back in 2000, almost 25% of the code was somewhere around complexity level 100. And even if we don't care about what exactly that level means that was fairly complicated. And over time, then we have sort of eradicated all those really complicated parts, and we're only more and more parts, bigger and bigger chunks of the code has less score. That means being less complicated. And of course, less complicated, that means more number of functions, and sometimes that's worse for when you want to read something, like how does it work? And suddenly you'll find a lot of sub-functions instead of one huge, and depending on your taste, that could be good and bad. But overall, it makes the functions smaller, and each function is easier to read and understand. And reading and understanding code is, of course, important to when you want to debug it, understand it, or extend it. And I've done basically the same thing then for function, because function length is not strictly complexity, but a really long function is certainly never easy to read and understand, possibly if it's not just one switch or whatever. But anyway, so I basically graphed the same thing. The longest functions in curl shouldn't be that long. We should split them up and make it easier. And that's why here's the graph for the longest function in curl. It was over 3,000 lines there in the beginning, late 2024. Now it's at 570. Still, now we actually have the CI job that verifies that the function is too long. It actually has this particular function is whitelisted, so this is the only function that is allowed to be longer than 500. Otherwise, it'll get a red CI bill. Just to make sure that we keep things in check. We don't accidentally just slip up and let it grow. And by then, since we're then, so here's the average length of a function. So now it's down to 35 lines. But it then also shows that the number of functions, of course, take off, because if we shrink the functions, we get more functions. And then we have almost 4,000 functions in Chrome. Yeah. And I mean, none of that is super important. That's just one of my things I'm trying to work on over time to make sure that the curl code is still decently easy to read and understand. 13,900 bug fixes. It's kind of fun to have all bug fixes since the dawn of time documented. I think we were not as good as documenting all the bug fixes in the beginning, so maybe we didn't actually count them correctly the first few years. But in recent years, we certainly count all the bugs pretty in a pretty high detail. So yes, 2,100 bug fixes over the last year. So number of bug fixes, and the bug fix rate is the red one here. So we're at somewhere around 6 bugs fixed per day on average, and that's kind of amazing. I mean, shouldn't it flatten out at some point? I guess it shows that we're adding bugs at roughly that rate, and we're fixing them at that rate too. So yeah, that's what we're doing. We're adding and fixing bugs. That's what we do. That's our business. And it's, I think, when the recent growth here, I think we're also seeing, hey, there's a bug on here. 2024 twice. So I think the recent growth here has been the AI explosion. So we have certain end end of 2025, beginning of 2026, has suddenly we had this explosion in AI tooling reports. But I figured that this might go on for a little bit more. My part of commits is slowly shrinking. My share of number of commits in curl since the beginning of time. That's the green thing here. So I'm actually slightly over 50% since the beginning. I'm far below 50% on the year to year nowadays. But since so many in the beginning, I can still sort of continue on my old practices. And looking at commits per month, with, back again then that I re-imported the code in late '99, so this is everything we have in Git, so we don't have the first few years. And we started with using Git in 2010, so there's also related to this. It's introducing Git changed our working model a bit. But anyway, I think it shows quite clearly that somewhere around here we started being more active. And as you can see, the last few years we've been more active than ever before in history when it comes to Git commits at least. And traditionally, I mean, since the last 5-10 years when we have CIs, we actually do fewer commits, right? Because in the beginning, we did many more commits because then you had to have all those oops, I broke a build commit over and over and over, right? Because we didn't have CIs until 2013 or something. So number of commits per year. Last year sort of went through the roof. So way more than ever before. I think maybe we won't have as many this year, but it's certainly going to be an active year this year as well.
Can you go back on the two previous one? Could you add the number of contributors on this one somewhere?
I can, but I have that in.
Because if you put it in like next to the number of commits, you can see if the contributors are like if it's increasing because of contributors or because of.
Yeah, but I have that separately, so I can tell you that it's not.
Okay.
So the number of contributors, it does not match this. I'll show you because I have another one. So number of commit authors per year, for example. I mean, this is not done per month, this is per year, but you can see that it's not growing in the same way. Okay, 2026 is weird, right, because it's only May, so. But anyway, we can see that the last few years we have not. It seems to have been pretty much flatlined. I mean, we were at 158 in 2018. We were at 154 last year. So that seems to be where we're at, about 150 per year, maybe a little bit more some years. COVID years, a few bit more. So counting back then to how many are contributing. So if you're just counting how many people in curl have done 10 commits or more, that's also really stable. That's 1 year and 15. Mostly seems to be around 13, maybe 11. So that's where we are. That's the core people in curl. I get a lot of questions, from people that ask me how many people are involved in curl, and that's such a weird question, right? But I don't know. What do you mean? How are you involved? I mean, are you all involved or you're not? I mean, there's such a gray zone, right? You're not in or out. Most people are just a little bit in or mostly out or vice versa. But this, I guess, shows then how many at least did 10 commits. Yes, if you did 10 commits in a calendar year, that's what I consider a core team. So that's what it looks like. And if you look at the green thing there, that shows the number of commits those people have done in repositories. So if you see here that so far in 2026, 6 persons have done 10 commits, and they have done 94% of all commits. So 6 person have done 94%. Also, you can also view it like this. How many persons does it take to make 70% of all commits? The last few years, 3 or 2. I think the last last year and this year, that's me and Victor, because I think we go way over 70% combined. Mostly just, there's actually no value in this. This is mostly just facts. This is how it looks like if you just check on Git. So we keep track of all contributors pretty detailed, so that we give credits reported by, suggested by, assisted by in Git commits, so that we just say thanks to everyone who helps out. And by doing that, we also can count how many people that we're actually saying thanks to. The number of names now in our thanks list is 3,687. At least the other day when I checked. So that's a significant number, and it keeps growing at about this rate over time. Possibly it's sort of a little bit down so that it goes faster and faster, so possibly a few more every year. Which is a little bit of amazing in itself too, but there are many people out there, so many people just find the bug once, report it, and then will never come back. But of course, that's good too. So number of contributors up, number of commit authors up, 107 new since I did this check last year. So that's an indication compared to the other graph. Last year, when I said this, when I showed this exact same slide, it said 106 new, I think. So that's where we're at. Still kind of cool. That's 100 new authors every year. Yeah, I have another fun graph about that. I'll show you in a second. Of course, top 20 curl authors the last 12 months. So these are basically the authors that have. So the number 20 did 3 commits. That's Jim. And so this is basically the top author. I mean, I said 100 authors, so there's a whole long tail here. But most of those other ones here, they have done 1 commit, and they will never come back. So yeah, this is what it looks like. And this list of people, this is, 17 out of these people are the same that I showed on this slide last year, and the year before that, and the year before that. So it's, we might move around a little bit, but it's basically the same set of people. There are a few newcomers, but still, it's a good set of people. And if you just compare them to all time, it's a little bit different, because some of these people that have contributed a lot in the past, some of them just vanished over time. So several of the top committers here, they have not been around for 10 years or more, even in some cases. And people always say that I've highlighted the bot ones here, because when I show it, people always say, hey, there's a bot in there, and in the previous one there were 2 bots. And why do we use the bots there? And it's a little bit weird, how do we get credit to the bot commit, right? But these are basically just updates to the CI script. Hey, a new version of this dependency has been released. Update your CI script so that we use the latest version. Often really stupid like that, and we merge that commit, and the commit is then done by renovate or dependabot, so we just leave that here. So that's why there is. So it's the top 20 author all time. And committing code as a separate from authoring code. These are the only people that have committed code to code. We're only, I'll show you that later too. There's only a subset of people, of course, that can commit and push them to Git. And I think this shows that me and Victor, we do most of it. And here's the other graph I wanted to show. So this shows number of authors in curl over time. The top one, the blue, is not the unique number of authors, 1,470 something. And what's fun is the green one, which is below. That's this number of commit authors who ever only authored once. They only have 1 commit with their name in Git. It's like approaching 1,000 of those now. So I think it's around 65% of everyone who ever authored something in Curl did it once and never again. Which is, I mean, it's unfortunate because we of course want everyone to feel welcome and do it again. At the same time, an improvement is an improvement. There's this new thing. I'm going to save it probably for tomorrow, but I'm just going to highlight that now when I'm talking about single commit authors. There's been this new trend that I've been sort of warned about, in that there's this new thing people call, reputation farming. That nowadays people are sort of warning projects like us about people trying to get the reputation up just by doing a single commit in a high visibility project like Perl, so that they can get reputation up, so that they can do something bad later in another repository. But from my point of view, that's a really weird kind of logic, right? Because how would we know if they do it? I mean, if it's back to that XZ thing back in the day. Let's call Jiapan a he, but he was an excellent contributor in the project, right? He did a lot of good things. Did they do bad in the beginning when they accepted his good stuff? Or, I mean, when did it switch? What I'm saying is, if someone contributes good stuff, that's the good stuff. It's really hard to say, is it good stuff with bad intentions? We can't tell. So therefore, I feel a rather, like, I can't help if anyone is trying to be the reputation farming on curl if they're contributing good stuff, because how can I tell? Good stuff is good stuff. We merge good stuff.
I believe the warnings are about the low quality stuff that just people try to make it through, even though it doesn't really contribute anything useful to the project.
Right, but if it's bad, it's bad, right?
Yeah.
But then it's sort of, if it's low quality and just junk, then we won't merge it anyway, and then it won't contribute. So, and I mean, a lot of PRs we will of course refuse because they're not good enough, or maybe it doesn't add stuff that we want, or so. I feel that's kind of natural, but the good stuff, it's hard to say no to good stuff just because you think the person might. No, I don't know. How would we know?
I think they are special because other projects might feel bad for rejecting the contribution, so they might bring it in.
Yeah, but you can still feel bad because sometimes you can feel that here's someone, he shows up, eager, shows up in your project, and you can totally tell that this person has spent time and energy on something. Yeah, I want this added, and we just shut it down immediately. No, we don't want this. And of course it feels bad because you can feel that. And back again to the green one, that we want to be welcoming. We want to enable that they actually show up again and feel something for the project and want to help them contribute. So we know that of course if they come with a big patch and we shoot it down immediately, the chance of them coming back again with a second patch is slim. So of course, but we also don't want to accept stuff we don't want. So we have to say no, but we have to say no in a way that hopefully doesn't make the person end up in tears. So back to the question, how many authors we have per month? It is on average then somewhere around 22 authors per month. And out of those 22, about 7 or 8 are new every month, which is also fascinating. But that also shows that green graph. They are new, but they won't come back in a lot of cases. And we can ever say. And it also goes back, a lot of people ask me questions about those people, but we don't know them, right? And in the project, we really rarely care about the individuals behind the contributions, and they often use pseudonyms or anything. We don't know them. They just show, there's a name there, there's a weird avatar and a weird nickname, and I have no idea in which continent, country, religion, we don't know, and we usually don't even care, right? If it's a good contribution, it's a good contribution, and we say thanks and hope that they will stick around and come back. But we don't know. And only because we never saw them before, it doesn't mean that they're newbies or bad guys, right? It could be excellent. And we know that over the time we've seen it many times that it could also be, someone is working on one of these giant companies, but they will show up with a pseudonym account just to hide their origins, right? So it could be just, an experienced guy showing up without wanting to reveal who they are. Could be anything. Back to this question, figuring out basically the origin of code. So I have this script, just counts how many names are still, when you do git blame on existing source code, how many names are still in there. So basically, how many names are we adding, and some over time, of course, when we refactor things, we remove code, and then some names we get lost again, because if you add a single line of code in curl, over time that line will go away. And now we have 570 something names left in code, and we've hit the peak, so we've gone down a little bit, which means that with all this constant refactoring, we're also getting rid of people's code. And of course, this is a little bit unfair, because if you now only remove code, of course, your name won't be seen in git blame. So removing code is, of course, not visible. So this is, I don't know what it says. It just says something that there's a lot of people involved, and there are still over 500 persons' names in a git blame on curl code. And out of the top people, there are 9 names with more than 1,000 lines, and there are 3 names with more than 10,000 lines of code. Me, Victor, and Stefan. All right, that's the one, but it's totally impossible to read. But that's me, Stefan, and Victor. Sure, we have the most number of lines of code still. Another thing that's totally possibly not visible on this brightness level is that this heat map of commit hours in the curl repository shows a distinct European presence in the project, or a distinct other than Europe activity. I mean, this is really dark than when we have done a lot of commits, and really light, bright when we haven't done a lot of commits. So you can certainly see early Euro mornings in the weekends, we don't commit a lot, or late night hours Euro-wise. So, and work days, Monday to Friday, we do a lot of commits. It just shows that this is one way to show that the distribution of commits is really Euro-focused. We can see that otherwise as well, but this is just one way to see it. It is no surprise. Again, me, Stefan, Victor, who had all those, we're all in Europe, and a bunch of the others, top authors, are also Europeans. We have a few others. There are a few North Americans, there are a few Asians, but overall, I think that doesn't really show the sort of collected statistics like this. So the maintainers of curl, the people in the curl team at the GitHub repository are these 15 people. And out of these 15 people, there are probably names on this that you recognize, and you haven't basically never seen commit anything because they did it 20 years ago. I think it's still fine. But these are all that actually can push a change to the Git repository. Possibly we should trim this list a little bit further going forward, because some of these have really dropped off the earth and we haven't seen them in a long time, so maybe they shouldn't be here for security. So we have this core team, curl security team. We actually sort of have a combined role, and these 7 people are the ones in there. Where nowadays, mostly what this means that you get the luxury of reading HackerOne issues at a really high pace, and you have to deal with all that, mostly from Josh. No, it's not. But that's what, I think that's the most stuff, that's what we do primarily. Read HackerOne reports, assess them, figure out what they mean, are they security problems, how bad are they, or should we dismiss them? Yeah, but we're basically, I bring this up every year. Maybe we should move out a few of the people in this list, because when you're idle, why should you remain in it? At some point, there's a security risk to have people that haven't been around for 10 years. I mean, who knows? Maybe their account isn't even there anymore. I don't know. At least we have these secure 2FA requirements. So their GitHub account should be decently safe. I don't know. Yeah, I'll just bring that up because it's something we keep on thinking about and we need to get back on reiterating it. I wonder if we should just take a coffee break. I have a few more things to say about this, but maybe we could just take a short break and drink something and get something. So 5 minutes just.
To mute.
Yeah, it's complicated, but I figured.
You know how to mute the thing?
Yeah, muting.
Choose by AI.
So as you can see, I have a lot of graphs, and you know that. The number of days between each release we've done curl as a graph, and I in particular I used to emphasize this because it shows when we mess up, because then we get one of those really low points. So if we have a really low, it means that we have a very short number of days between releases, and that's bad because then we do one of these patch releases. Patch releases is a sign of us messing up somewhere. And so yeah, we've probably possibly reduced the number of patch releases a little bit recently. We have this release candidate policy since a while back, and it works really well, in particular thanks to the Debian team, because now they also ship and build them for Debian experimental. And part of that process is rerunning test cases that are depending on the Perl. So a lot of extra tests are running on the pre-releases, and I think that has helped. It has made us improve quality. We do less regressions, fewer patch releases now, which I think is good. And of course, the question is always, when do we need to do a patch release, right? What is a regression? I mean, we tend to have regressions in pretty much every release, but we have this discussion in the current team. Is this regression important enough to do a patch release? And of course, it's a judgment call. What is an important regression? To the persons who experience a regression, every regression is super annoying and they want to have a patch release. But to us, it's also a big process to do a release, and yeah, that's what we're working on. And since I don't remember, we've been doing 8-week release cycles since 12, 14 years, something, and looking at the graph, it looks like, yeah, we're keeping track. We're doing releases roughly at the same rate over a very long period of time. Release number 275, I think, the next release is. So, number of releases per year, then it basically just, this is mostly just then a function of how many patch releases we do. Since we do releases every 8 weeks, typically, so we can figure out how many that would be per year, but then we add in a few patch releases so that we do a little bit more occasionally. Other activities in the project, number of created issues and pull requests in the curl. As you can see, basically from 2024 something happened, and now we're doing things a lot more on GitHub. Many more, in primarily pull requests are sort of really going through the roof. The number of open issues and pull requests at any point in time in curl, I think we work really hard and keeping this number low. Some will say that we're doing it a little bit too hard, but we're making sure that nothing just sits there idle. An issue that is submitted to curl, someone has a problem, if it remains in the GitHub repository for too long, we will just document it as a known bug and close the issue in GitHub, because we don't believe in having lingering crap on GitHub. We do have, occasionally there will be a few anyway, but we're working hard on it. We were actually down to 0 open issues a while ago. Now I think we have 10. So yeah, the total number is then kept fairly low, which is, I think, is super convenient because it really makes us able to keep focus on these. We can basically have all open ones sort of in our heads. And we managed pretty well at doing that. And when we do close things, when we do pull requests, and those pull requests fix the issues and closes the pull request itself, we do that with these GitHub instructions in the commit message. And the time the pull request and the issue has been in GitHub, the time it has been there until we close them has also sort of just gone down. So nowadays we're closing them at a median time is somewhere around 5 hours until we close them. So we're really on it. And people tend to ask me about, well, where's those, easy to work on issues if you're a newbie in projects? We don't have any easy issues to work on. And that's a little bit unfortunate for the newbies who want an easy issue to work on, but it's also a luxury problem. Like if there's ever an easy issue, someone will fix that instantly. And we don't just keep a few issues around just to help them. No, they're getting fixed. So it's a pretty high bar and threshold to actually find something in curl to work on and fix. I mean, we have a long list of known bugs and documented sort of problems, but there's a reason they are there because no one has sort of gone to that. So it's not that easy to find something as an entry issue. That's both good and bad. And I tend to show this because this is the end of the mailing list as a way of communication, just shown as a graph because it was really this at some point in time. And nowadays it's not that hard. And from I was actually, my plan was originally to do the annual curl user survey before curl up this year, so that we could have that as a discussion point and have a separate session about that. But I was basically too lazy to do this, so this year I haven't done it yet. So the plan is to do it soon. So this slide is mostly here as a reminder. If you, I have a separate repository for the entire annual survey, all the questions, and that's the one I'm supposed going to run soon. If you have ideas or thoughts about what to ask users about, because since this is basically the only way we have to get feedback from people out there who are actually using curl without us just blindly guessing, which we do a lot anyway. But this is one way to at least try to get feedback from users, and typically around 1,000 to 2,000 users are actually answering, so we can get some kind of info. What are people using, thinking, how are we doing? And so yeah, the plan is to run it soon, whenever that is. And I just want to mention also, so we're running the curl website through Fastly. Fastly is a CDN, so when you go to curl.sc, you're not hitting my server or our server, you're hitting Fastly servers. They're on hundreds of places all over the world. We serve 890 terabytes from the last 12 months. It's a serious amount of data. That's up 35% from this time last year. So what are people doing? We have no idea. That's 180 billion requests. So you would imagine that, well, then maybe they're downloading curl. But no, they're not. So out of those 118 billion requests, 0.01% of them are actually downloading something that is larger than 1 megabyte and smaller than 10 megabytes, because that's the only information I have, because we have no logs and we have no tracing. So the only thing I have accumulated data from Fastly says, so this many objects have been downloaded. 0.01% of 100 billion requests. Yeah, that's 12 million downloads. I mean, that's not a lot, I think, for a whole year, for 890 terabytes. So clearly, there's a lot of bots. I don't know. There are other things I can deduct from the stats that I get from Fastly. So, for example, it gives me accumulated distribution of HTTP versions used, for example. And if you're looking at a normal user-focused website, you should have a certain distribution of HTTP traffic based on what users are using, right? And that should mean quite a lot of HTTP3, quite a lot of HTTP2, because that's what people are using in browsers with Chrome and whatever, but not on curl.sc. It's almost all HTTP1, which hints about bots. And I've asked Fastly about this huge load, and they mostly don't care. So I'm not bothered. But to them, that's not a lot of data. To them, that's just, yeah, they don't care. And if they don't care, I don't care as much either.
Why do you not collect any logs? Because you seem to have a lot of graphs about curl itself, but you seem to be fine with not being informed about what the curl.sc is.
But the problem with website and logs, there are many. first, of course, it's just the privacy thing that I would sort of suddenly know things about visitors. But then there's just the volume and the infrastructure that I need to capture these logs. Because, I mean, these are incoming requests from 100 different points in the world, right? They have to send their logs, 118 billion ones a year, to a single server somewhere. So who's going to run? And sure, then there are commercial services for running those logs things, right? But then I would have to pay for it, and then I would get the logs there. So basically, I don't think it's worth the money and the effort. And so for me, it's more I'm good with not knowing. And then I'm also good with saying that we don't have any tracing, we don't have any logs. No one has any logs at all and also, you know, no cookies, no trackers, no ads, nothing. I feel pretty good about that as well. So I'm good with this, even though it leaves me in a situation where I have no idea what 890 terabytes. That's a lot of data. But it's a fast site. It's close to most users, so it works really well. And Fastly are happy to do this for us, and I'm happy that they do it for us. So it's great. On GitHub then, we just counting something silly like GitHub stars. I don't know why, but it's a metric to count how many people have clicked the GitHub star. But there's a lot of forks. I guess people don't remove the forks after they did their single pull request and then they leave it. So there's 7,000 forks on GitHub. But what's back to weird stats on traffic. 54,000 Git clones per day from GitHub. That's a lot. And up from last year. It's more than doubled since last year. So what are everyone doing? Again, I suppose it's just a lot of CI jobs it's our CI jobs that that's a lot, but then there's also a lot of other CI jobs probably. I don't know. That's like one clone, more than one every other second at least, right? Because it's 86,000 seconds per day. So yeah, a lot. Somewhere around 30 billion installations. I struggle with sort of getting a fair number here. There's also a question how you count installations. So I usually throw this number around because every mobile device, basically, and every mobile device has curl in a number of installations. It's in iOS, it's in all Androids pretty much, I think. And then in a lot of really high volumes apps separately, right? So do we count that? I mean, YouTube, Google Photos, all of those have their own installations of curl, so it's in a random ordinary phone, it's going to be 5 or 10 curl installations. I don't know, 30 billion. It makes a really nice graph if you Bezier curve it. I imagine that it's going to sort of flatten out because I can't sort of come up with, when you're on every mobile device, you know, everything else is just going to be a rounding error or something. We can't really add this number much now. How? It's sort of, even if we would suddenly run on every printer, it wouldn't sort of, would just be tiny, tiny blip up there. Even we could probably run on every printer. I don't know. Yeah, I did this. I don't have this slide here, but I did this check just this year. How many I updated my check how many car models that are actually running curl, and I found 47 car brands using curl, which should be almost all cars used. So this is sort of my own, now shown very, very dark, so you can't see it. All of these are products running curl. Not really visible here. But the question is always then sort of, does it matter? Are these users real? When it comes to these, the numbers are fun, just because it's sort of, yeah, it's fun to say 30 billion, it's sort of mind-boggling. But it's also a question of, what if it's enough with one of these users saying, we'll use something else, and tomorrow the number could drop to a lot less. And these are just, some of those are just one user, really. I mean, that's one developer at a big tech company in the west coast of the US who did something. Tomorrow they will do something else, and the numbers going to go up or down. And it doesn't really matter to us, right? Because we're working on it the same way either way. They don't participate, they don't contribute, so it really doesn't matter. All of those numbers are completely, it doesn't matter if they're real or not. I'm not going to change them. We can just as well just imagine that they don't exist or it's not real, because what's really more whoever is around who does something, adds something. We have a bunch of sponsors in the current project. These are the same ones that have been around for, I've shown pretty much, I've removed I used to have the month and year in the title, but I realized that if I don't have that, I can just use the same slide year after year, because it's the same companies. So basically, Prague is sponsored primarily by the same companies since many years back. And we're on Open Collective, where so I should just sort of specify, so these are the big sponsors that are actually contributing more than $100 per month, because we have this on Open Collective, we have a silver sponsor level, which is $100 per month, which adds, I think we're 12, 15 silver sponsors that are adding $100. So that gathers up a lot over time, because that's 15, 20 per month over a long time, and that adds up. So on our balance on Open Collective is now at $133,000, which actually is then 10K more than last year. So obviously we have at least not spent more than we're getting. The amounts here are usually not enough for us to pay anyone full time. So it's not, we can't really hire an engineer in a Western country for this money. But so we're using this money for this sort of thing. So the fun thing that to check on Open Collective, that I saved the screenshot I did last year, so that we could sort of just see what's the difference between last year and this year in who's contributing most amount of money on Open Collective. And the Open Collective is weird, or people are weird in general, yes. So are you an organization or are you an individual? I mean, that's the difficult question, apparently, because people can select that, I guess, when they pay money. So I'll show you, because then Open Collective separates organizations from individuals, but I'll show you in a second that the individuals sound very much like companies too, so I don't know. I guess it's a matter of which credit card you're using or something. But anyway, so you can see that there's a bunch of these companies that have, some of them, which is, I mean, the interesting, it's not visible, you can see the last time they paid anything. This is since basically when they started to pay something. And several of these cases are just single time donors, like Indeed and Backblaze and Bloomberg, number 3, 5, and 7, they just paid once years ago, and they're still up there. And that's why they're at the same amount of money last year. Maybe too dark to read that. But that's how it showed. And then a bunch of the others are these repetitive, just been paying $100 per month for a long time. Of course, we appreciate it because they make things like this possible. And the individuals then, Comcast, that individual, similar thing, a single donation in 2021. But still, money. HackerOne, another individual. And at HackerOne, we have this. The unfortunate thing, I mean, that's $17,000 to the current project, and the unfortunate thing of us closing down the bug bounty is that HackerOne used to pay 20% of every bug bounty to us. You know, we could write ourselves a minivan, right? But when we closed down the bug bounty, we also took down that money to ourselves, so no more money from HackerOne. Yeah, it just shows that we're getting money, at least. They're incoming and outgoing. We pay for curl SC hosting. So basically all expenses around the current SC runs on an origin that I maintain, and we have run a lot of other services on that too, like the mailing list and the primary DNS and stuff like that. So we pay for this. So we pay for this venue. We pay for top current contributors to come here and stay here. And the very important part is the stickers, live stickers if you need current stickers. Primarily the stickers are handed out at FOSDEM, because at FOSDEM, for some reason, there seems to be an unlimited demand for stickers, which I think is fun. But you know, this year I brought, I think, 3,000 curve stickers. So I had a few hundred when I got back home. So it's fun. Also probably rather pointless, but it's fun and sort of keeps the brand up. And so, yeah, and we have been paying developers on and off with this fund also. We're probably going to continue to do that. As long as we keep getting money in, we can also spend the money on things that we think are beneficial for the project. It's a little bit self-serving because the core team is then paying core team members for doing it. But okay. Of course, we're always then also open to figuring out other ways to use the fund in ways that would be good for the project. So we have the curl.sc, the CDN, sponsored by Fastly, that basically just say, hey, use whatever you need. I don't know exactly the value of this. It's quite a lot, 880 terabytes per year. It's worth at least thousands of USD per month. We have CI services paid for by TeamViewer on AppWayer, and GitHub sponsors the part on the GitHub CI, the workflows there. And the fun thing about us being on GitHub, because it's worth just reiterating, so I'm not going to say how much that is valued at, because it's so much that I rather they don't think about it, so I'm not mentioning it. Because one of these days they're going to look at the price tag and say, wait a minute. So let's not talk about that. But this is, I mean, whenever in open source context, people are going to say, why are you still on GitHub when there's Codeberg or GitLab or something else than GitHub? And then we always bring up, what about the CI services? Have you looked at the bill here? GitHub just eats this for us, and we're sort of at I don't know what they did, but we're at the enterprise on. So there's unlimited CPU and unlimited parallelism. So we just add more CI and use runs. That's why we do 220, 230 CI jobs in 10 minutes. It just works. It's an awesome thing, and it really helps us to keep curl at this level and all these tests and all these things. So it's not that easy for us to just say, hey, we should ditch GitHub tomorrow, because I'm sure they won't just say, hey, we'll run your CI even if you're on some other service. I'm pretty sure they won't do like that. So from my point of view, I think they're pretty good friends of ours, because they take that pretty good. We have an Anycast DNS that's being managed by this Swedish company called Curate, friends of mine. Anycast, of course, is fun. It makes DNS faster and more reliable. And why not? It's cool. Some other things that happen. We keep on. I mentioned this. I'll just reiterate a little bit that we keep on removing things from the project. We want to. We got the number of lines of code down, and that's because we took away support for things we don't want to support anymore. Secure transport, bare SSL, MSH3, WinBuild, build system, and all of these other things that we determined are not stuff that we should support anymore. The TLS libraries, because they don't support TLS 103, the MSH3 backend, because it really didn't work for us. WinBuild build system, because we thought we should we have too many build systems, we just should narrow it down to make it easier. No one is using Windows SCE, we should remove that, and Visual Studio old stuff, older OpenSSL support. XP, finally we dropped XP support. It's about time. We dropped OpenSSL quick, because it didn't really work, and we already have two others that work better and reduce complexity, focus on what works. Older, get rid of a lot of things that people are not really using. And back again to the question about what people are using. That's why we needed the user survey to get some kind of guidance. And of course, when I say no one is using it, everyone, I mean, every one of these are going to get a certain percentage of users. Nothing gets zero for some reason. Whatever we ask about, there's going to be 2 users using it. But at some point, you know, are they real? Are they really using Gopher? I don't know. They say they do. RTMP, we ditched it finally anyway, for other reasons as well, because RTMP is, you know, built with a third-party dependency that's basically not maintained, no test cases, a really old legacy protocol being used right now when we stream it over Twitch, but no, it's not used. SMB version 1, where translating actually became opt-in, so it's actually not removed yet. The same with NTLMs, it's on its way out, both of them. So we're trying to simplify, get rid of stuff that no one seems to be using, that only adds complexity for us, or if that code. We keep having a lot of things experimental, and experimental is a way for us to introduce code and, you know, try it out and allow people to test things before we carve it in stone and say this is how it works, now we'll never change the API and API again. The difficult part of doing things experimentally is then when do we stop having them experimentally? Because as long as we have them experimental, very few people are actually testing them. So it's a little bit of a, I don't know, catch-22.
So maybe we can have some input in that. We did discuss it a bit in our common containers block in Brazil, and we are going to enable it on Debian Unstable and testing because it's like what you said. I mean, if it's experimental, we might not enable on Debian Unstable because it's experimental, but then people won't use it. So we are going to enable everything, and before the stable release, we are going to reevaluate if we keep it enabled or disable it for the stable release. But that's something that I'd like to discuss with you guys. Like, maybe when should we remove from the experimental label and like do.
Yes, yeah, and it's also hard to have a generic rule for when to do it because they're all rather unique, right? Maybe they're all, I mean, like these features that we have, HTTPS RR, a DNS record, right, for information about what connection details about where you're about to connect, how to connect to that site, and in particular ECH information, ECH being encrypted client hello, which is a way to encrypt the SNI field in TLS, right? The final little piece in TLS that is before ECH is still in the plane, right? If you connect to a TLS site today, the host name is in there in the clear, in the TLS handshake, right? You're announcing to the world who you're going to connect to, not that private. ECH is changing that. So, and in order to support ECH, you need to have a key first. So you need to encrypt the host name, right? So how do you know how to encrypt the host name to a host you're never connected to? You get that through the HTTPS DNS record. So those are sort of the keys. You need HTTPS in order to do ECH. So we just need to make sure that we have figured that out, or rather that we have the API and ABI correctly set, so that we can. And I need, of course, your help to try it out once in a while and then remove it from experimental. I think those two, the first ones, I think we should be able to remove them soon because they're mostly hidden inside the current machinery. We don't it's not that particularly hard external API to satisfy. And I don't think we're giving away too much internals by just saying it should work. So 2026 goal, we should get rid of those from the experimental piece. HTTP 3 with a quiche backend. Quiche is naming is great, right? So when you're about to do, I mean, imagine that you're one of these really big giant tech companies and you're about to do a quick library. What do you call it? If you happen to be a giant, you call them quiche because two of them are called quiche. So both Google's and Cloudflare's libraries are actually called quiche, but this is the Cloudflare quiche. So you can build curl with HTTP3 support with the Cloudflare quiche, and it works, but we still have it experimental because they haven't decided that they have a stable version, so it's not a stable API from their point of view. And I also think we have a known bug, outstanding issue still, that we have some weird behavior that they don't consider very important, but it's breaking test cases for us. So we think that's a pretty good sign that maybe we should just keep it experimental. And I think, I don't actually know this, but my theory is that Cloudflare, they don't really care much about the outside world using their stuff. So they have no real pressure in making this API sort of stable and release-worthy. So they're not working on this very hard, and I don't think we care about it much either, because we then push for it to be 3 done with ngTCP2, and that's where the world is going, and that's where I think for us it's valuable to keep the support for this, because now we're down to 2 HTTP backends in curl, and I think it's valuable to keep 2, because then we have that selection still there. If we remove this, we're down to 1, and then it's probably going to be 1 forever then, because then we're never going to be able to go back. So I think it's still slightly worth it to have this, just to have the ability to select between backends. Maybe. In HTTP2, for example, we don't have any selection, we just have 1 backend. So maybe that's the future. I don't know. Rust, that's a great name, right? To pronounce. I think they call it Russell's. I don't know. Yeah, and that's also experimental. Also a bit of an ABI question, I think. So Russell's is written in Rust, right? And so we're actually not using Russell's, we're using the Russell's FFI, because the FFI thing is the actual API that they export to the C world. And I don't think that's stable, I don't think that's I think they haven't sort of decided this is the API they want to provide to the world for the rest of times. So therefore we're a little bit of up in the air. What do we do? I don't think we can say that it's solid until they say it's solid, because we can't decide that for them. So I don't know what's the time plan for this is. I'm not sure it's that important. And back again, I don't know how many are using this either. This all goes back to this constant question about, curl should be memory safe, we should all be using Rust. But if you're then looking at, so who are using Rust? No one. So we should just all do that, but no one does it. When it comes to at least building curl with Rust stuff. That was the effort a few years ago when I sort of implemented a HTTP backend for curl in Rust. Sure, everyone can say that was a good idea, but no one is actually going to use it. So it's a little bit about, I don't know what it is. This is also sort of a niche feature that I figure we should just also remove from experimental. I'm not sure we're going to get users to actually use this without it. So it's really caught in this catch-22 world. Importing and exporting SSL, not TLS, is actually tickets as well. Basically, saving metadata that you can later import. For if you're, restarting curl later, and you can connect back to the same site again faster because it has a session. Basically, that's a shortcut in doing a faster handshake with the remote server, and that's key if you want to do TLS early data. That is. And early data being sending data even earlier in the TLS handshake. So what it means is basically reducing round trip time when you want to connect and send the data to TLS servers. Not super important to most people, I guess. I mentioned the release candidates. We started last year, and it seems to work really well. We have this established. It works well in the release cycle. We have this 8-week release cycle, and we do. Basically, when we stop accepting features, we only have we have an 8-week release cycle. 3 weeks out of those 8 weeks, we accept new features. Otherwise, we only accept bug fixes. And when we close that release window, we do the first release candidate, and then we do 2 more release candidates until we do the release. Seems to make a difference. This year, we also introduced even happier eyeballs, as we call it. Happy eyeballs is this method which a internet client, pretty much any internet client that connects to a host on the internet should be doing, because it means you resolve the host name and you get A's and quad A addresses back, and then you connect to both. You try to connect to both the IPv4 and IPv6 in parallel, and the one that works first, you go with. Happy Eyeballs is I think the first RFC is like 10 years old or something, so it's not a new concept. If you try this with a lot of command line tools today, they still don't do this, right? I'm not going to mention wget or SSH from OpenSSH, because they certainly do not do this. So then, if one of your IP families are broken, you might just get stuck, right? As in my case at home right now, my IPv6 is broken, but I get IPv6 addresses. So if I try SCP, it'll just get stuck because it doesn't work, and it won't try the other ones. Super annoying, but curl doesn't do that. Curl will try them all. And nowadays, there's a new version in progress called Happy Eyeballs version 3, and it gets much more complicated, because we had A addresses and we had quad A's, right? That was the easy word, just IPv4 and IPv6. But now I mentioned the HTTPS record here. The HTTPS record also contains addresses what to connect to. So now we said that we have A's, quad A's, and HTTPS, and the HTTPS record itself can have both IPv4 and IPv6 addresses. So, and then we have other things like vault services and things in HTTP. And we do things in curl also. So for example, when you ask curl to connect to an HTTP 3 server, if you don't specify anything else, we will try HTTP 3 and the other HTTP versions in parallel. So we're just, we're adding an explosion of different connection alternatives, all in parallel, and we go with the one that works first, kill all the others. In order to do that the best possible way, in curl we have, of course, a helper thread to do name resolving, because name resolving in a typical libc compatible way, if you want to support every protocol platform, you have to use getAddrInfo, and getAddrInfo is a synchronous blocking call, right? It's super annoying. So what if you want to time out your name resolver, or what if you want to do many in parallel? It's not possible with a standard API. So the only way to do that, or there are multiple ways, but one way to do it is to start new threads and just do the name resolving in the helper thread. That's what we've been doing in curl for a long time. But libcurl is a library, you can use that for example in a browser. There are a few browsers using libcurl. What if you started 100 transfers at the same time to different hostnames? Then you get 100 helper threads resolving hostnames. That's not only sort of ineffective, but it's also using a lot of stack and a lot of file descriptors, because we have lots of communication and all helper threads. So you get an explosion in memory use and file descriptor use, and that turns problematic at times. In the last release, we switched things around, so now we have a name resolver pool. If you start 100 transfers, we don't start 100 helper threads, we just start a number of threads and a pool of them, and a queue. So we only have X number of threads that will now do all the name resolving. Super complicated. Threads are horrible and queuing, and it's a recipe for disaster, messing things up. But it seems to have been working pretty well. Not that many problems. We got a few bug reports, but I think most of the bug reports turned out to be the applications doing strange assumptions about what's actually happening under the hood. And we also introduced then another fun thing is, in order to do Happy Eyeballs the best possible way, you need to do separate name resolve for the IPv4 addresses and the IPv6 addresses. I mean, traditionally you ask for all of them at the same time, right? Because you want them all. But it turns out to be that in many cases you can get one of them much faster than the other set. So you don't want to wait for them all before you start connecting, because then you always have to wait for the slowest one. So now instead you ask for the IPv4 and IPv6 concurrently at the same time, and the millisecond you get something back, you can start trying to connect to that. So if you get an IPv4 address back really fast, you start with those. If you get the IPv6 really fast, you start with those. And then once you've started, you can then add more addresses when the other responses get back, and then add HTTPS records on that. So this, it's a whole maze of things. So It's all Stefan. So we don't know how that works. We just ask Stefan. He says that it works.
And if one of the IP aliases does not respond, then you call back to other names, IP addresses for it.
But okay, yeah, but it's okay. No. It's more complicated than that. So in a case, like if you go to curl.se, curl has 4 IPv4 addresses and 8 IPv6 addresses, right? So you connect, that's 12 addresses. So curl will start with it actually, if you get them all at the same time, which you probably don't, but if you would you would start with the IPv6 address because there's a slight preference for IPv6, and then if you there's a delay before you start with IPv4 because it's meant to prioritize IPv6. So you start with IPv6 and then you start with IPv4 and they go concurrently. And if you try HTTP3, it'll start HTTP3 over IPv6, then IPv4 HTTP3, and then it'll start IPv6 HTTP2 and IPv4 HTTP2. So there are going to be 4 of them in parallel after 100 milliseconds. And if none of them has started, and if none of them works within, 100, 200 milliseconds, then you go on to the next address, the next IPv6 address. And we used to previously then cancel the previous attempt, but now we don't. So now we just add another one. So basically, if the first connection attempt hasn't succeeded within 200 milliseconds, we start the second one. So the second IPv6 for HTTP3 then starts. And if that hasn't succeeded within X milliseconds, we start the second HTTP3 IPv4 attempt. And so on. So, nowadays we have a maximum. I think you can only get up to 16 parallel connect attempts or something. But it's so, and of course, so then we basically we try the next IP address. So in curl.se's case, you have 8 IPv6 addresses to try. One of them should work, but if none of them works, it'll fail. And if all the IPv6 addresses fail, it won't connect to IPv6, but it'll come, and then it'll sort of iterate through the IPv4 addresses, and eventually, hopefully, one of those work. But if none works, they're all going to fail. That's how we iterate through them all. The idea being that, of course, that it should find a working one, and it should find a working one as fast as possible. And if you ask for HTTP3, it should prioritize HTTP3 to HTTP2, but not necessarily if the HTTP2 one is faster. So complicated.
So when one of the connections does begin a data flow, you cancel the others and go on with that one?
Yeah. So the winner takes it all. As soon as, and then, the real question is really, at what point is the connection considered done, right? How far do you allow all these connections to go before you kill them? So, and that's also, I think we've been sort of been experimenting a little bit differently, right? Does the connection include verification of the certificate, for example? Because X amount of these IP addresses might actually fail a certificate check, while some of them might not. So, and it's also been a little bit different between the different protocols, like HTTP3 and HTTP2. So in HTTP3, it's done over QUIC, right? And QUIC is a transport protocol, and the transport protocol itself has the certificate check there. But in HTTP2, it's done over TCP and TLS, and so TCP is a transport protocol, and it does not have the certificate check. So it's a lot of moving parts there. But of course, the end goal being that we should connect faster and more reliable to most hosts. And it has been, we've already introduced all of this, so it works pretty well, let's say. So Stefan has done a marvelous job on that. And we continue to have our video meetings every week, actually. A bunch of us who wants to participate. So if you ever feel that you want to talk curl more regularly, hit us up and we will invite you. It's really casual, mostly just chit-chatting about the recent curl stuff, complaining, and trying to figure out what to do and how to navigate forward. The Everything Curl book is also slowly moving forward. at 119,000 words. So I started this thing in 2015 as a way to get a documentation that wouldn't just be the man pages, but it would more explain the things. But it's really hard to do that. It's hard to write documentation, and it's hard to keep up, and it's hard to write explainers like that. But every once in a while, I try to polish it and add stuff, so it's there. I think it works. It helps sometimes. And you can see on this little graph that I sort of made an effort recently to just went through and added a bunch of things that since we're adding things and changing things over time, if I don't pay attention to this book, it'll sort of slowly degrade, and that's also annoying. So I have to get back to it every once in a while and make sure that it actually still is correct. And it's a separate Git repository, and it's rendered online, and it's rendered a PDF. The PDF is like almost 600 pages now. So it's a monster. And we used to have it in print. Dan did some amazing prints back in the day, but that was done. Now we don't have it in print.
Let's look at emails every once in a while from people who are interested, so maybe it's worthwhile doing another one.
One of these days.
Yeah, 600 pages, you say?
Yeah, we could probably. What about really, really tiny paper?
Thin paper.
Exactly, really, really thin paper.
The Bible of curl.
Yeah. So, and we're of course we have these other side hassles. So we do Trural. I haven't done much with Trural lately, other than sort of brokerage testing a few times because we did some. Or I am doing silly assumptions in the test suite for Trural, and then I changed the code so that the test broke. But it seems to be it works. I think it's pretty cool. It's just a little command line tool for URL parsing and then manipulating. If you're writing shell scripts and you need to manipulate and work with URLs, it helps. wcurl. I don't remember exactly when, but it's. We have adopted it into the curl repository. We ship it in releases, even though it's maintained and handled in a separate repository. It's just the idea being the single use case: download a URL or multiple URLs onto a file on your local disk. Basically, what everyone is saying to me, whispering that they are actually using wget. I don't care, but in many cases, wcurl actually fulfills the exact same use case. One command, one URL, or multiple URLs, and it'll download that. So in many cases, if that is the use case, wcurl will do that for you. And it's useful in all those cases where people already have curl installed, because this of course uses curl, the command line tool, to do that. And it helps a lot of it. You don't have to install the separate tool if you don't want to. And this basically works. I'm not sure exactly if there's any particularly changes planned for it, but it's there, it works, people are using it, and seems to be. We've seen some distros switching to this instead of wget. So, I don't know. It's there and it works. So some of the things that are less good in the project are basically the same things that I've done every year, but possibly a little bit better this year, because I always had this flaky CI thing, and at least I crossed it over, because it's less flaky this year, even if you can see that Victor is making faces, but he's Mr. CI here. So yeah, we still have a few flaky tests. So everyone who has done a PR to curl will see that sometimes you get a red job, but it certainly wasn't your fault, it's just a stupid something. And recently, back again to being on GitHub, GitHub has certainly been less stable than curl recently. So yeah, every once in a while you get 42 red builds, and none of them were our fault. They were all, for some reason, in particular, installing packages from an Azure URL seems to be really hard for GitHub. And we have certainly no slow CI anymore, because recently, mostly thanks to a lot of work from Victor, our CI jobs are now amazingly fast. And it was not many years ago when we had CI jobs that were in the 6-8 hours range for completing the last one, and now they're in 10 minutes. So it's kind of an amazing transition, and it certainly allows us to work differently, right? When you're pretty confident in 10 minutes, when everything is green, it allows you to maybe stay in focus a little bit longer and keep working on the same thing instead of, in the past days, you would just submit that and go do something else for the rest of the day before you would know how your task would actually be until much later. But of course, we're still doing, we're still writing bugs, and we're still creating vulnerabilities, and we're still fixing a lot of vulnerabilities. I'm not sure if, I mean, less good. Of course, it would be better to not have any vulnerabilities at all, but I don't know how that is possible. And I certainly do a mistake all the time. And I think this year, I have a special security thing that I'll talk tomorrow about, but this year, this is going to explode. So I'm pretty confident that any project, open source or not, that are keeping a focus on code this year, everyone is going to explode in number of vulnerabilities this year. So if they're not, they're probably asleep. But we're not going to be an exception. We're going to publish a lot of vulnerabilities. And of course, we're doing still a fair amount of regressions, but I don't know. There's no way to avoid this. We're trying to add test cases for everything, but it's hard to write tests. Even if nowadays we also add a lot of AIs help us to review codes and review PRs. And I think we're over time making better PRs than ever, but we still do regressions every once in a while. And we certainly identify test gaps, and I think we're reducing the test gaps, in particular when we remove a lot of these old crap. It's like RTMP, not tested at all. It's sort of an embarrassment, but rip that out, and suddenly the test gap is gone as well. So ideally we can do more of that going forward, or just identify them and work on them. And of course we have this struggle, and I think, I mean, we're not alone in this graying of open source in general. I mean, all of us maintainers with the gray hair, and all sort of, the saying that the average age of the maintainers in curl is suddenly increasing 1 year every year. And I don't have any way out of that other than just trying to be open and friendly to everyone. And my role then, you won't see this because it's too dark, but I actually got myself another medal this year, actually. And this is a gold medal that I got from the Royal Engineering and Sciences in Sweden. Actually, a pretty cool gala event at the same hall that they hand out the Nobel Prize in. So I brought so this is my family at that event. That's sort of fancy photo. So I had a black tie event. I had to rent one of these things. It was fun. It was a good evening.
Wait a second, your tie is white. What's going on with that?
The bow tie is white. It's supposed to be white. I got I asked when I rented it. I asked the lady, "It's supposed to be white?" And so she looked at me. Are you mad? Of course it should be white. So you're not a waiter.
It's not a black tie.
So apparently waiters, they don't have whites. So no, the dress code says white bow tie. It needs to be white. And what I also learned at this, dress code wise, how do you know? It turns out that now that I have a medal that I can actually wear, it's actually allowed and sort of encouraged in the dress code. So in a black tie event, you can also wear your medal. Just as a sort of, hint. Remember that. So yeah, I do all of these things. You know what I do. I do a lot of things. I don't know why I have this here. Anyway, and I just always want to emphasize that the project, me, and the commercial side of things are three different things. I try to keep them apart. They sometimes don't stay apart, but I try to keep them apart. I try to do what I think is best for all of them independently. And I am sort of, sure, I might be the BDF. I try not to decree things as a dictator, because I don't want to be the one to sort of, I don't want to decide things or point at things that no one else agrees with. So I want us to have an open discussion about everything, and I try to listen in before. I basically never I never really point with my hand and say we should do this. Of course, I understand that whenever I say something that I think this is what I think, it might sort of be interpreted a little bit like that, but it's usually we're a big bunch of people, and whatever people say is important. So if many people think one way, we usually go that way. I don't know what, I get that question a lot, right? Do you have a transition plan? And no, there's no transition plan. It's not gonna, even though I'm not gonna be around forever, it's not for life, I mean, whose life? But it doesn't matter. If I would stop being in the curl project, it would work out anyway. If someone else would take over, and ideally, hopefully, I will not just do it suddenly one day and be gone. It'll be some kind of transition period anyway. And there's a lot of people out there. Everything is also always public, documented. There are no secrets there. Everything is in there already. It doesn't really. No one needs me here.
How's your son C programming?
Yeah, he's at university now, and he's doing a lot of Python and Go at least. So, back to the grading, people don't actually learn C these days at university. So maybe I should get him into that. So I don't think my kids are the future. So yeah, in 2026, what we're going to do. Nothing magic. I think we're going to do a lot. We're going to try to do more tested CIs, and we're going to add a lot of, Python security, and we're going to do a bazillion of CVEs. That's no surprise. We're already at the end of April. That's sort of the first 4 months. We announced our 18th CVE for the year, and that's basically what we typically do in a full year, a normal year, and. We have 11 more in the queue, and that's half this release cycle. I'm pretty sure there's going to be much more than 11 by the end of June when we do release. It's going to be a total explosion. I'll show you more about that tomorrow. So, but releases every 8 weeks, get more developers involved, and yeah. And a lot of this, I have this weird roadmap webinar every year, because that seems to be what some customer wants. But I don't know what we're going to add in curl this year. We have a few pull requests that we know that we would want to merge because they're already here, so it's easy to say. But what else? There's no secret plan. I don't know what the future holds. And most of the things that we merge, they just show up during the year. Someone has done something and wants something, and they just show up and make a pull request for it. And I'm sure that's going to work out this year as well. And then we work with those contributors, polish everything, get it done, and then we merge that, and then we have that feature. So I don't know what everyone is going to bring to the table this year. We'll have to see. We're going to keep removing things. We're going to remove weird TLS SRP. I don't know why we ever introduced that. It's a TLS 1.2 thing for doing authentication in TLS. It's not even supported in TLS 1.3 with it. And back to SMB, we had it opt-in already. We're going to remove support completely. It's only support for SMB version 1, which is dropped for anyone from Microsoft did it years ago. Just because it's version 1.2, basically you can't use it against anything. So I don't know. No one is going to miss this. So get rid of it. And TLM is one of these horrible authentication methods. It's a proprietary Microsoft thing. They don't support it anymore since a few years back. It's used by SMB, so sort of in there, and it's also used for HTTP authentication. And it's super awful when it comes to HTTP. So it's going to be really good to get rid of that. And TLM in itself uses DES and something else that is also completely outdated security-wise. So it's sort of not good for anything. If there's anything that has a user here, there's going to be like 3 users still stuck somewhere in TLM.
We might be.
Yeah. So, but and then NTLM is no. So let's not get into that. There's also a negotiate authentication method that in itself can fall back to what we have within negotiate. It's another Microsoft thing. But the plan is to get rid of NTLM and we'll all get a little bit easier to breathe. And I mean, you can build curl, right, with billions of different build combinations, and you can build curl with, I said, 11 different TLS backends. And you can still build curl completely without TLS, even though you would imagine that that's not too many users actually. But you can still do that and still support it. And if you build curl without TLS, you don't have any crypto library because the crypto library comes with the TLS library. So if you don't have any crypto functions, how do you do digest authentication? Because for digest, you need MD5 or SHA-256. So curl has local crypto implementations for when you build without TLS. We're going to drop that. So if you need those features, you need TLS as well, which I think is a fair thing to do. We don't want our local crypto implementation, less code, less things to test, less sort of legacy crap. And I bet it's not going to hurt a lot of users. So that's what we're going to do. So continue to trim off weak things. We're going to add things then, basically that. I mentioned HPSRR several times, it's age. We have this huge new patch, 7,000 lines to add HTTP 3 over old proxies and old HTTP over HTTP 3 proxies. So why not add, a whole new weird combination of different protocols over different other protocols? And then you ask why, but people are actually using this. And it's also a way forward here because it's also, if you imagine a world in the future where you would at one point remove some protocols from the mix, then you need to do the newer protocols or the older protocols over newer proxies and so. That's what these do. They also allow tunneling of things in ways that people are using. The masked protocols. We have support for HTTP message signatures coming in. RFC 9421 is basically a way to get hash number of in your request. You send a bunch of HTTP headers. You can hash all the contents of those headers and send the hash or the signature of those headers in the request. Basically making sure that at some point in the receiving end you can verify that the headers you're interested in have not been modified in your chain of HTTP internally. Apparently it's a thing, it's being used by the Fediverse. I think this is a standard version of something that Amazon is using, the AWS CQB4, basically the same thing, done completely differently, but this is at least the ITF version of it. And we have a nice PR for this already. It's going to add command line options and other things. So yeah, everything is going to be more, so basically everything in the world is getting more and more network connected. More power, more networks, more internet, and therefore more curl, even going forward. I think this sort of observation still helps, because I think this has been the trend for the last 10 years, right? And I think it's going to continue for a while more. So that means that basically this is sort of the future. So more stuff over time. And not only more curl everywhere over time, and more stuff in curl also over time. So, I've talked a long time. So that's it. We're not done yet. That's the conclusion. So any questions? Anything we should add to that?